Good morning, class. We are looking at Chapter 8, further applications of trigonometric functions. Here's 8.6, vectors. So we covered just about everything, and now 8.6 vectors. The objectives are graph vectors, find a position vector, add and subtract vectors algebraically, find a scalar multiple and the magnitude of a vector, find a unit vector, find a vector from its direction and magnitude, model with vectors. So a quick recap of polar coordinates. If you think about rectangular coordinate system, we have x and y axes. In the case of a polar, we have the x axis, the positive side, the polar axis, and the pole. When we put them together, a point P has coordinates x comma y or r comma theta. Rectangular would be x comma y, polar would be r comma theta, x squared plus y squared equals r squared, Pythagorean theorem. Tan theta is y over x, and you have to adjust for the quadrant. Polar, which is r comma theta, to rectangular, x comma y, x is r cosine theta, y is r sine theta. Think about this. Sine of theta, y over r, cosine of theta, x. Polar is not unique. Polar with coordinates r comma theta can be represented as r comma theta and 2k pi, theta plus 2k pi, or if you want to change the r to negative, you add odd multiples of pi, theta plus pi plus 2k pi. And of course, k is an integer. So if you look at rectangular and polar grids, look at this, couple of points, and look at this, a couple of points. You start with the angle first, and then you go, in this case, pi over 4, and then 2 tick marks, 5 pi over 4, and 4 tick marks. The tick marks are along the circles, concentric circles we have. This one is R, equals 1, 2, 3, and so forth. And this, in essence, is putting the two together, showing you the x-axis, the y-axis, the x-axis, or the angle is 0. In this case, the y-axis, the angle is pi over 2, and a couple of points that you can see. Note, pole has coordinates r comma theta, where r is 0 with any angle. When r is 0, it represents the pole. So it doesn't have to be 0, 0. The complex plane, the Moir's theorem summary, what did we cover? A complex number, it's nothing brand new, a plus bi, you remember that. X plus yi, or a plus bi, where x and y are real numbers, and I is square root of negative 1 is an imaginary number. And as you recall, I is square root of negative 1. I squared is negative 1, I cubed is negative I, and I to the power of 4 is 1. The magnitude, also called the modulus of z, is the distance from the origin to the point x comma y. We put it in looks like an absolute value. Sine is equal to r, or square root of x squared plus y squared. Z is x plus yi, that a plus bi in essence. Its conjugate, complex conjugate, is x minus yi. Okay. The conjugate for a plus bi was a minus bi, as you recall. And the modulus, or the magnitude z, is r, or square root of x squared plus y squared, or the product of z bar under the radical. As you may recall, a plus bi times a minus bi, we showed that it was a squared plus b squared. X equals r cosine theta, just like polar. Y equals r sine theta. And normally we use r to be positive and theta between 0 and 2 pi. Complex numbers in polar form, z equals x plus yi is the standard form, or rectangular form. The polar form is r cosine theta plus I r sine theta, and short r cis theta, C for cosine I for I, and S for sine or cis theta. So you're looking at a complex plane. The x-axis is the real axis, the y-axis is the imaginary axis. So z is x plus yi, which is r cosine theta plus I sine theta, or r cis theta. R is positive, theta is between 0 and 2 pi. So we go in a positive direction. So again, we are repeating the same concept, and I'm adding r e to the power of I theta. That's by definition. You can look at the proof that we have in the previous section. Now, when we want to multiply two complex numbers, if we go with the polar format, makes it very easy. R1, R2 times cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So you multiply the r's and then you add up their arguments. And it's a shorthand notation. Okay. Division. If I want to divide z1 by z2, and if I go with the polar format, I divide r1 by r2 and cosine of their difference in argument, cosine of theta minus 1, theta sub 1 minus theta sub 2, I sine of theta 1 minus theta 2, or simply r1 over r2 cis. Cis is the shorthand notation, theta 1 minus theta 2. The Morse theorem says if n is larger than or equal to 1, if we want to raise z to the power of n, we raise r to the power of n, and then we multiply the argument theta by n, or simply put z to the power of n is r to the power of n, cis n theta. If we want to take a root where w is represented as r cis theta sub 0, or cosine theta sub 0, plus I sine theta sub 0, and n is larger than or equal to 2, there are n distinct complex nth roots of w. So nth root of r, cis, you divide theta sub 0 by n, and you add 2k pi divided by n, and k goes from 0 to n minus 1. Or if it's in degrees, you put 360 degrees k over n. Either way is fine. So that's the synopsis of complex plane de Morse theorem. And now we want to go to the new section, vectors. Geometric vectors and scalars. Vector is a quantity that has both magnitude and direction. Scalar is a quantity that has magnitude only. Examples: weight versus mass, velocity versus speed. In other words, magnitude as well as direction. So in a positive direction, we go with positive value. In the negative direction, we go with the negative value. Its absolute value in its magnitude becomes scalar in essence. So velocity versus speed, because with velocity, we can say going towards what direction. So if you're doing 100 miles per hour going north, in essence, you're doing negative 100 miles per hour going south. The speed in both cases is 100 miles per hour. So here's the line containing P and Q, 2 points on it. Here's a line segment, PQ. We have a bar at top. It goes from P to Q. Now, if you have a directed line segment, PQ, where P is the initial point, Q is the terminal point, we put an arrow at the terminal point, and this directed line segment is called a vector PQ, and we put a small arrow at top of it. This is the notation that is used. So, given a vector PQ, we normally put a small arrow at top. Magnitude is distance from P to Q. So the distance is representing the magnitude. Direction is the direction from the initial point to the terminal point, from P to Q. So if you look at all of these, vectors are equal. V equals PQ, V equals W, if they have the same magnitude and direction. Same direction, obviously, when they are parallel, they have the same direction. And the magnitude can be calculated. So PQ, RS, TU, they are all the same because they are parallel and they have the same magnitude. So that's getting us started with the concept of vectors, everybody. Now, vector properties of addition and scalar products. Vector addition is commutative and associative. If you have vectors V and W and scalars, that means constant, that means numbers alpha and beta. Alpha and beta are two numbers. V and W are two vectors, okay? So V plus W is W plus V. When you add two vectors, it doesn't matter in what order. So that makes it commutative. If you have three of them, it doesn't matter in what order, U plus, a parenthesis, V plus W, or U plus V plus W. That means associative. So commutative, associative. V plus 0 is 0 plus V equals V, and this 0 is a 0 vector. That's why sometimes they just go with this. They go with an arrow at top. Okay. And V and negative V, they add up to 0, is a vector that is in the opposite, meaning it's parallel to that, but it's in the opposite direction, the same magnitude. Definition of difference. V minus W is V plus the opposite of W, just as we did in operation of numbers. Properties of scalar product, multiplying vectors by numbers geometrically, what happens? So if I multiply 0 by a vector, I get 0. 1 by a vector, I get the same one. Negative 1 by a vector, I get minus V. That means I change the direction. It goes towards the opposite. Alpha and beta are numbers. Alpha plus beta times V, I can distribute alpha V plus beta. Alpha times V plus W, I can distribute. And alpha times beta times V, I can use the distributive property of the product. Notice, if this is V, as long as it's in the same direction, that means parallel to that, then the magnitude, if it's 2 times this is 2V. If it's identical to that in size, but in a different direction, in the opposite direction, it's minus V. Adding vectors geometrically, we have this is the V, initial point of a V. This is terminal point of V connecting to the initial point of W. This is the terminal point of W. From the initial point of V to terminal point of W is V plus W. So connect the two in this manner. More time. You have two vectors. The terminal point for V and the initial point for W are connected. And now from the initial point of V to the terminal point of W. And order is not important. This is W, V. You can say W plus V or V plus W. Please understand these two are identical because they have the same size and the same direction. These two are identical for the same reason. That's cumulative uh, property which says order is not important if you have two pieces. Remember, A plus B is B plus A. So V plus W is W plus V in any order you do it. Associative property says U plus V plus W, you do it in any order, U plus V plus W. So take a look at what happens. So U, V, and W. Notice the terminal point of U, the initial point of V, the terminal point of V, the initial point of W, and connected. So this would be U plus V plus W, okay? So what you have here, this is U plus V, and then plus W gives you this. Or V and W gives you this one. Now U and V plus W. So that means put it in any order. The result is the red one, which is the sum of all three. U, V, this is U plus V, this one, and W. And then V and W is this one, U plus that. Opposite vectors, V and its opposite, they add up to 0. That means V plus negative V is 0. So V and negative V have the same magnitude, but they have different directions. So we end up with 0 vector. 0 vector, V plus 0, 0 plus V equals V, or this one is 0 vector. The difference V minus W is the same as V plus the opposite of W. So how do we do that? Here's V, here's W, and here's negative W. So if you think about that, one easy way is to connect their terminal points. So that would be V minus W. Of course, this is V plus W, okay? But think about this. V is the same as this one. W is this one. This is minus W. If you look at this one, this is V minus W. So again, V is the same as this one. W is this one. This is the, because we are going in the opposite direction. If it was the same direction, it would be the same as W. Opposite direction is minus W. So look at this one. The terminal point of V and initial point of negative W, they are connected. So you go this way. So V minus W means the terminal point of W goes to terminal point of V in essence. So these are adding vectors geometrically. So V minus W, and there is. So pretty straightforward, everybody. And so we are given the vector v, w, and u, and we are going to find the following graphing vectors: v minus w. So w is going this way, minus w goes that way. So this is parallel to that, same size, but in the opposite direction. This is minus w, and this is the answer. So you can see the graph v minus w, v minus w. You want to graph the resulting vector. Okay, everybody. Two v, so that means it's v just extended by the same amount. That becomes 2v. Then this is w just extended by 3 times. So this is 2v. And this is 3 times w in this direction. This is 3w, 3 times the size. This is not to scale, everybody, but you get the picture. So 2v, 3w, this is the answer. Pretty straightforward, everybody. Two v, we have it. Minus w, we have it. And then plus u. So we are going to say this is 2v. This is minus w, right? The same as this one, as long as it's parallel, is the same thing. Now u, put it here. So this is minus w, just the same as this one. This is u, just the same as this one. So notice this, this. So we combine them into the following. Pretty straightforward, everybody. Magnitude of vectors. So this is the norm or magnitude symbol. There seems to be, an absolute value, but you have two of it. That's the symbol. To compute the magnitude and direction of a vector, an algebraic way of representing vectors is needed. So we come up with what's called the position vector. If a v is the vector, and this is the vector notation, a comma b is an algebraic vector whose initial point is at the origin, then v is called a position vector. So what is a position vector? The initial point must be at the origin. Therefore, algebraic vector is ai plus bj. I is the unit vector along the x, j is the unit vector along the y-axis. So v equals ai plus bj, or with the brackets, these are special brackets, vectors, a comma b, where a and b are called components of the vector v. So what are the components? A and b, components. And magnitude of the vector, this is the magnitude, is square root of a squared plus b squared. The magnitude is the distance from O to P. Magnitude is distance from O to P. And this one is A, this one is B. There's nothing brand new. This is just Pythagorean theorem class. Square root of a squared plus b squared. So the magnitude of any vector is always greater than or equal to 0. Can it be 0? Yeah, for a 0 vector, the magnitude is 0. But everything else is positive, okay? Magnitude is different than direction. If the magnitude is 0, then the vector must be a 0 vector, v equals 0. The magnitude of two vectors that are opposite are the same. So the magnitude of minus v and v are the same. If two vectors are opposite vectors, they must have identical magnitudes. The magnitude of a vector times a, it's the same as absolute value of a times magnitude of v. Remember, the magnitude is always positive. A, even if it's a negative number, its absolute value is positive, and that's the key. Finally, unit vector. A vector u called a unit vector if its magnitude is equal to 1. Any vector that has a magnitude of 1 is called the unit vector. We're going to take it from there. All right. Find position vector. A vector with initial and terminal points P has coordinates x sub 1 and y sub 1, and Q has coordinates x sub 2, y sub 2, is equal to position vector PQ, V equals PQ. So x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. Or position vector V, V is vector P1, P2, vector with components A, B, such that A is x sub 2 minus x sub 1, and B is y sub 2 minus y sub 1. And I want to remind you, this is called brackets, angle brackets, sometimes known as chevron, are used to represent vectors. So they represent vectors. That's as far as terminology. Brackets, parentheses, braces, so on and so forth. So we wanted to make sure that we know the name. So take a look. We have this vector. Here's the initial point. Here's the terminal point. We basically move it such that the initial point is at the origin. And the terminal point has coordinates a comma b. Now the terminal points a comma b would be x sub 2 minus x sub 1, y sub 2 minus y sub 1. So the change in x, the change in y. That's the definition of a position vector. Here's a Simple example to make some sense out of it. Find the position vector of the vector v is p1, p2, such that p1 is -1 and 2, p2 is 4, comma 6. So the initial point has those coordinates. The terminal point has those coordinates. So basically, we are going to use this one, right? So P1 has these coordinates, -1 and 2. You can locate that. P2 has these coordinates, 4 and 6. You can locate that. Now we want to move it here. Want to move it here. So what are basically, so the initial would be 0, 0. The question is, okay, what would be the terminal point? Okay, so x sub 2 minus x sub 1, y sub 2 minus y sub 1. So 4 minus -1, 6 minus 2. So this is 4 plus 1, 5. This is 6 minus 2, 4. Very simple. So now the initial point moves to 0, 0. And the terminal point has coordinates 5, comma 4. They are paired. Pretty straightforward. Theorem, vector equality. Two vectors are equal if their corresponding components are equal. So here's the position vector, a comma b, which has coordinates x sub 2 minus x sub 1, comma y sub 2 minus y sub 1. So if v has those is the following vector a1, b1, and it's equal to w a2, b2, then a1 and a2, b1 and b2 must be the same. Vector quality says components must be identical. Unit vector is a vector u such that its magnitude is equal to 1. That's the definition of a unit vector. Magnitude is 1. Now, unit vector I and j, I have mentioned that already. V has coordinates a comma b, a times 1, 0, b times 0, 1, ai plus bj. That's another way of writing it. I is along the x-axis. So location would be 1, 0 for the terminal point. J is along the y-axis. Location for the terminal point would be 0, 1. Both of them, of course, these are position functions. Therefore, 0, 0 is the initial. So any vector can be represented as ai plus bj. Find the position vector of the vector v equals pq bar such that p is 4, 9, q is 4, 6. So simply put x sub 2 minus x sub 1, y sub 2 minus y sub 1. So we are saying 4 minus 4, 6 minus 9. So 0 minus 3. This is one way to write it, and you're done. If you want to go with ai plus bj, a is 0, so you don't have to write it. B is negative, so negative 3j is the answer. The down arrow in essence. Find the vector from its direction and magnitude. Remember a vector, P1, P2 vector, as components A and B. unit vector is defined such that the magnitude is 1. So unit vector in the direction of v, if we have a vector v, and we want to find the unit vector in its direction, all we have to do divided by its magnitude, v divided by its magnitude. Find a vector from its direction and magnitude. So v would be the magnitude times cosine alpha I plus sine alpha j. And I hope you recognize that this in essence is a unit circle. Cosine squared plus sine squared equals 1. Remember that, and the square root is 1. So the idea is that cosine alpha, this is alpha, cosine alpha, sine alpha, okay, represents a unit circle. My apologies. Unit vector. And so when you multiply by its magnitude, that gives you the vector actually. So the magnitude of vector, remember, is square root of a squared plus b squared. The unit vector in the same direction would be dividing the vector by its magnitude. Therefore, any vector is the product of these two. The vector is the product of these two. And this unit vector is this, that's why. Cosine alpha I plus sine alpha j. Here's a simple example to make some sense out of this. Find the vector v whose magnitude is 7. So this is given as 7. And whose component in the I direction is both positive and equal to the component in the j direction. Well, we know this to be 7, right? So we can write a squared plus b squared is 7 squared. And in this case, we want a equals b. So write a squared plus b squared equals 7 squared. And since a and b are identical, we are dealing with 2a squared equals 49 divided by 2. Take a root. A becomes square root of 49 divided by square root of 2. If you rationalize it, you get this one, 7 square root of 2 divided by 2. So what is the vector? 7 square root of 2 over I plus 7 square root of 2 times I plus 7 square root of 2 over 2 times j, or you can write 7 square root of 2 over 2 times I plus j. You can even write it in that fashion. So pretty straightforward. Finding a unit vector. Unit vector is defined such that the magnitude is 1, and in the direction of v, unit vector is v divided by its magnitude. And magnitude of a vector, we said, is square root of a squared plus b squared, and v is the magnitude times 0. This is nothing brand new, so let's look at an example. Find a unit vector in the same direction for the vector v equals negative 3i plus 4j. So all you have to do, divide this by its magnitude. So first, we need to find the magnitude, square root of a squared plus b squared, where a is negative 3 and b is 4. We are using this. A is negative 3, b is 4. Everybody knows this is 9 and this is 16, so you get 25, comes out as And so what is the unit vector? This one divided by this one in the same direction. So negative 3 over 5i plus 4 over 5 times g. And you really should check to be on the safe side. If this is a unit vector, the magnitude of this vector must be 1. So square root of a squared plus b squared must be 1. This is the a minus 3 over 5 quantity squared plus 4, 5 quantity squared. And you know, this is 9 over 25, 16 over 25. It adds up to 1. And you proved, you checked, everything is 1. Find the vector from its direction and magnitude. So we are given the fact that v is the magnitude times cosine of alpha I plus sine alpha j. Okay. Magnitude is this, direction angle alpha between v, the vector, and I. The direction is with the positive side of the x. Okay, everybody? Positive side of the x, remember that. Which is alpha. So cosine alpha, sine alpha. We want to find the direction angle of V, which has components negative 3i and 3j. So if we go with this, we are going 3 to the left, 3 up. So in other words, just plot the pair negative 3 comma 3. This means class, plot the pair that point, and then draw a vector from the origin. That's it. So we are in the second quadrant. Tan theta is y over x. Tan theta is y over x. We've seen this many times before, and we are in the second quadrant. It's -1. And as you know, theta is negative pi over 4 or negative 45 degrees. And you add 180, you get the 135 degrees. So if you want to go with the, if you go with the inverse function class, if you said theta is tan inverse of -1, it gives you minus 45 degrees or minus pi over 4. You have to add 180 degrees. So it puts you in the second quadrant. So you have to know the quadrant or it doesn't work. So we found the angle. Theta is 135 degrees. That's what we are looking for. Find the direction. Find the vector v whose magnitude is 9 and the angle it makes with the positive x-axis is 225 degrees. That means the direction is 225 degrees. The magnitude is square root of a squared plus b squared is 9. That's given. Alpha is 225 degrees. And so we put it into this formula. The magnitude is 9 cosine of 225 degrees I, sine of 225 degrees j, or simply put, if you go with a, I, and bj, a is cosine times this, and b is sine times that. So 225 degrees. The reference arc, if you subtract 180 from it, gives you 45 degrees. So the answer is the same as 45 degrees in the third quadrant. Sine and cosine are both negative. Both of them are square root of 2 over 2, and both of them are negative. Because sine and cosine of 45 degrees is what? Square root of 2 over 2, and both of them negative. So 9 times negative square root of 2 over 2, 9 times negative square root of 2 over 2, and it results in the following. The vector is minus 9 square root of 2 over 2, I minus 9 square root of 2 over 2, j. Again, depends how they want it. When you answer the question, they may want just a and b. They may want ai plus bj. You have all of them under control. You decide according to the question how to answer. Add and subtract vectors algebraically. Vector properties of addition and scalar product. Vectors v and w are a1i and b1j, a1b1, w is a2i, b2j, a2bt, and scalar alpha. Alpha is a real number. So if you want to add them up, just add up their components, everybody. Okay? The I components and the J components, they get added up. And if you want to subtract them, just subtract their components. So V plus W would be A1 plus A2 times I plus B1 plus B2 times J. And this is the components, the same format for subtraction. So if V has components A1, B1, and W has components A2, B2, V plus W has components A1 plus A2, comma B1 plus B2. That's the idea. If I multiply it by some number, some constant alpha, every component gets multiplied by alpha. So if V has components A1, B1, alpha V has the same components times alpha, alpha A1, comma alpha B1. Okay, and it shows those components. Magnitude of the vector, we already know that. So the magnitude is this distance from O to P1. We have seen this before. There is not much to it. Add and subtract. V is given, W is given. We want to find V plus W. Just add them up. When you add them up, you add up the components, meaning you add up these two. You get negative I. These two, you get negative J. That's what adding is all about. Subtract. So this is minus 2I plus 5J. These two negative 5I. These two plus 9J. That's how you do it. Very simple. Find the scalar multiple and the magnitude of the vector. V is given, W is given. We want 3 times V. So multiply this one by 3. Now, whether you multiply this one or this one, again, it depends how they want it. So each one gets multiplied by 3. This is negative 9. This is 12 components. Or, again, if you did this one, just for the sake of argument, everybody, if you did this one, it would have been minus 9i plus 12j. So that's the same thing again. 2v minus 3w, just do it again. And times 2, you get minus 6 and 8. Times 3, you get 6 and minus 15. And so you can say plus minus 6 plus 15. This one and this one, negative 12. This one and this one, 23. So you do the components accordingly. What is the magnitude of V is square root of A squared plus B squared, which is negative 3 quantity squared plus 4 quantity squared. And we've seen this 25 and comes out as 5 many times before. Resultant force, F1 and F2, just add them up. F1 plus F2. And here's a simple example. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree, and reminding everyone of those. Tan alpha is B over A if we go with A and or Y over X. You remember that. And so with that being the case, let's see what we have here. First and foremost, so the plane is flying. 200 miles per hour is the magnitude. North, 55 degrees east. North, 55 degrees east. And so if this is 55 degrees, this angle must be 35 degrees, right, everybody? Now, the magnitude for V is 200 miles per hour. And this angle, which is theta of A, remember, direction, in this case, alpha for this vector is 35 degrees. It's going north 55 degrees east, but the vector direction is 35 degrees. Remember the positive angle from the positive side of the x-axis, 35 degrees. And the wind is going this way because it's going to go from west to east at 35 miles per hour. So the speed or magnitude is 35 miles per hour. And the angle, because it's parallel to this one, is 0, right? This makes no angle, so 0 degree. So if we want to go with the component for this guy, we're going to go with this. V is the magnitude times cosine alpha I plus sine alpha j. We are going to go with this one. Okay, and this is the sum of the two, by the way. And this one has angle theta, okay? This is angle theta. The ground speed, that would be the ground, this V sub g, this is the ground speed. The magnitude of that would be the ground speed. And the true course The true course would be we have to find this angle. So the magnitude of this one is the ground speed. And if we find this one, we are going north. This angle, which is 90 minus theta, going east. So north, 90 degrees minus theta going east. I hope everybody's following that. So with that being the case, V sub A is 200 cosine of 35i plus sine of 35j. This is not a common arc. You put it into a calculator. This one, cosine is 1, sine is 0. So simply put 35i. And you just add the components. So the velocity relative to the ground V sub g is the sum of these two. So if I add these two, these two components, because they're I components, they add up to 198.83i, and the j component doesn't change. So what is the magnitude of this vector? Take the magnitude, square root of this number. Square root of this number is squared plus this number is squared. Okay. So square this one, and take a root. Put it into a calculator. About 230 miles per hour. And what is tan of theta? B over A. So this number over this number. Tan of theta is this number, 114.72 over this number. And you put it into a calculator. Theta is tan inverse of this number, resulting in 30 degrees. So now you are going to say this is the true course. Okay, we are doing 230 miles per hour. The true course is north, 90 minus 30, 60 degrees east. 90 minus theta, 60 degree east. Example 10, an object in static equilibrium, a box that weighs 1,200 pounds, is suspended by two cables, as shown. Find the tension magnitude in each cable. All right, just a little bit of a lesson from physics. Free body diagram looks like that. So you draw the same thing such that you have a grid, you have a rectangular coordinate system. So this is the x-axis, this is the y-axis, this angle is 45 degrees, and now you call them F1, F2, F3, okay? And this angle is 30 degrees, which means this angle must be 150 degrees, okay? Remember, we want angles. When we look at this alpha is the positive direction of angle, okay? So this is a free body diagram. So what is it? Free body diagrams show two or more forces acting on an object or body. If the object is in an equilibrium state, all forces must add up to 0. Now, F1 is the magnitude of F1 times, we are looking at this formula, cosine of 150i plus sine of 150j. F2 is the same thing, the magnitude of F2, but the angle is 45 degrees. So F2 is cosine of magnitude of F2 times cosine of 45i plus sine of 45j. F3 is simply 1200 pounds, which means negative 1200 J because of the direction. Or you can write this as 270 degrees. Put it here, this becomes 0, this becomes -1. So please understand F3, the weight is always towards the center of the gravity, center of the earth. Now, summation of F is 0. That means if you add them all up is 0. Summation of F sub I along the X and summation of F sub J along the J direction, the Y direction must also be 0. Why? Because it's the equilibrium state. That's in physics. So set them all equal to 0. So we're going to add these 3. By the way, 150 is the same as 30 degrees. In the second quadrant, cosine is negative, sine is positive. So sine is 1/2, cosine is negative square root of 3 over 2. 45 degrees is square root of 2 over 2 for both cases. So we are going to add them up. So this would be minus square root of 3 over 2, magnitude F1 times I, plus 1/2 magnitude F1 times J, and the rest of them. So we just add them up. That's all. We also know F sub I is 0. So anything involving I must be 0. So these two have I, add them up to 0. Minus square root of 3 over 2 magnitude of F1I plus square root of 2 over 2 magnitude of F sub 2I. That adds up to 0. And the rest of them involve J. Add them up to 0. Now, this is a system of equations. System of equations. We solve it. And I'll show you actually in the next page, just in case. You solve this system. It's a little bit involved. But what happens is that magnitude of F1 becomes 2400 over square root of 3 plus 1 precisely. You put it into a calculator, you get 878.5 pounds. And magnitude of F2 is square root of 3 over 2 times 2400 over square root of 3 plus 1 precisely. You put it into a calculator, you get that. How do we get that? I'll quickly show you in the next page, which is a system of equations. Everybody remembers we have done systems of equations. We're going to do it again in the next chapter, but we've seen it in elementary algebra, intermediate algebra, college algebra, you name it. And this is done. I just want to show you how we arrived at that. So to recap, equilibrium means summation of F is 0. And therefore, summation of F in any direction, in the I as well as the J direction must be 0 for it not to move in essence. That's the meaning of static. Now, we are putting these two together, okay? These two, I'm writing it here. So how do we solve that? A quick thing, we don't like the denominator. We're going to multiply this one by 2 and this one by 2. You can just watch what I'm doing. You know, you have that available too. So we get rid of the fractions. That's the first thing. Now you notice this is square root of 2, this is square root of 2. You can subtract one from the other, or you can multiply one by -1 first. If you multiply this one by -1, then add it to this one. And now when you add them up, what happens? These two cancel each other. These two add up to square root of 3 plus 1 times magnitude of F1 equals 2400. So please understand this means the sum of these two numbers. So what is F1? The magnitude, divide 2400 by square root of 3 plus 1. I showed you in the previous page, and it works out to be 878.5 pounds roughly. Then you use either the first or second equation. You always go to the original one, nothing in between. Maybe we made a mistake. So if you go to the first one and replace, and notice, first of all, again, we can drop the 2, right? And This, if you take this to the other side and divide it by square root of 2, you get magnitude of F2. So if you multiply this one by square root of 3 over 2, by the way, this is a class the same as square root of 3 over 2, and put it into a calculator. And by the way, when you want to do the rounding, notice I didn't use this one. I used this one. Again, the rounding takes place at the end. So 1075.9, about 1,076 pounds, roughly. So that's an application. Here's another one, weight of a piano. A piano is being pushed up a ramp, inclined at an angle of 20 degrees, with a force of magnitude 300 pounds. Find its weight. Well, it's being pushed this way, okay, parallel to the ramp at 300 pounds. So what is given? Let's make sure we understand this. So given theta is 20 degrees, that's what's given. And so is this one. We're going to discuss that in a moment. We are interested in, remember, the weight is the force towards the center of gravity, okay, perpendicular to the surface. So F1 is the weight, and we are looking for that. So we want the magnitude of that. F2, the magnitude is given as 300 pounds. F3 has a definition of a normal force. Again, a piece of information from physics. What do we mean by that? The normal force is a constant force applied by a surface on an object, or is a force acting perpendicular to the surface. This ramp perpendicular to that is called the normal. And what it does, this will undo the friction and then it sticks there. It doesn't go up or down. The normal force cancels out the friction. The friction force when it brings it down, the normal force when it keeps it. So this is 20 degrees and so is this one. So angle BAC and angle DBE, they are both 20 degrees. They are showing that, and I want to show you why this is the case. Angle B and C are 90 degrees. This is C is 90 degrees. This is B. This one is 90 degrees. This one is 90 degrees. So if this is 90 degrees, this angle and this angle, which means ABC and BAC, these two angles must add up to 90 degrees. Just these two angles must add up to 90 degrees. And this angle, this class, this is 90 degrees. So this angle must be 90 degrees too, right? This angle. That means this little one and this one. That means ABC and DBE, this one and this one must also add up to 90 degrees because this is 90 degrees, it's 180 degrees. Therefore, both of them become the same 20 degrees. That's a proof, believe it or not. But in any event, let's look at this triangle. This is a triangle DBE. Sine of 20 degrees is the opposite, which is F2 over the hypotenuse. This is opposite the 90 degrees over F1. Sine of 20 degrees, if F2 over is F2 over F1, the magnitude. And we know F2 has a magnitude of 300. And so F1 would be 300 divided by sine of 20, and you put it into a calculator, and you get the answer. It must be 877 pounds. That must be the weight. Find a unit vector in the same direction for this. As you know, we have to find the magnitude first. So square this one, square this one. 4 squared and negative 3 squared. We've seen this many times before. It ends up being 25 and comes out as 5. And the unit vector in the same direction is the same vector divided by its magnitude. So we get 4 over 5i minus 3 over 5j. Very similar to one of the questions we did not too long ago. And to check, if you square this one and this one, they must add up to 1. Just to remind you. This was done before. You should have no problem with that. So find the vector from its directional magnitude. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes angle of 30 degrees with the positive x-axis horizontal. Find the components of the velocity vector, horizontal and vertical, meaning this is going 25 miles per hour and making a 30-degree angle with the horizontal. And so what is given? The magnitude is 25 miles per hour of the vector v, and the alpha is 30 degrees. So we go with this and replace the magnitude with 25, alpha with 30 degrees to find the components. Cosine of 30 degrees squared of 3 over 2, sine is 1/2. We multiply by 25, and the components are that, which means along the x-axis is this one, along the y-axis is this one. So find the components of the velocity vector. Horizontal is this number, which is about 21.65. Remember, this is the magnitude, okay? And vertical is 25 halves or 12.5 miles per hour. So you're looking at V with 25 times cosine 30i plus sine 30j. And those are the numbers that were mentioned. So pretty straightforward. Finding actual speed and direction of an aircraft. A Boeing 737 aircraft headed due south maintained a constant speed of 500 miles per hour. The jet stream is 80 miles per hour in the northeast direction. Express the velocity v sub a of the 737 relative to air. This is velocity relative to air. And the velocity of v sub w, that is the wind, w of the jet stream, the wind, in terms of I and j. So let's see what's given. The magnitude for the speed of the airplane is 500 miles per hour, and the direction is south, which makes theta, remember, it's going down. You can say minus 90 degrees or 270 degrees. The wind has a magnitude of 80 miles per hour, and it's going northeast. Northeast means 45 degrees. Plus, this is north, this is east, in between. When they say northeast, you have to go with 45 degrees. So the velocity of 737 relative to the air is, use this formula. And cosine, by the way, again, negative 90 or 270 makes no difference. This is 0. And this is negative 1. So we get minus 500J. We do the same thing for the wind. So this is minus 500J. The wind is going, again, it's important to understand northeast means theta is 45 degrees. So put it into this. And you know cosine and sine are both square root of 2 over 2 when it comes to 45 degrees. Divide by 2, you get 40. So 40 square root of 2 times I plus j. So that's part A, everybody. Part B, find the velocity with respect to the ground, v sub g, of the 737 relative to the ground. That means add them up. And I'm writing what we found. This is from the previous page, okay? So just add them up. So please understand that this one is 40 square root of 2i. This is 40 square root of 2j minus 500. So I multiply these two, and then I can combine these two. So please understand that. So this can be combined with this. And there you have it. Now, find the actual speed and direction of 737 relative to the ground. In other words, when they say speed, find the magnitude, which is square root of a squared plus b squared. So what do we need to find? Check this out. This we can find. The magnitude we can find. After we find this angle we can find 90 minus that. So after we can find that this angle in green is 90 minus alpha. So direction, okay, would be south 90 degrees minus alpha east. So find the magnitude using this formula. Find this angle subtracted from 90 degrees. So let's do that. So the magnitude, you square this number, you square this number using a calculator, we get about 447 miles per hour. So we got the magnitude, 447 miles per hour. Now, what is alpha? Remember, tan of alpha is b over a. Tan of alpha is b over a. And if you put that into a calculator, that means put this one over this one. Put it into a calculator. That means alpha is tan inverse of this number. That gives you the exact answer in negative format. So alpha is negative 82.7. Alpha is negative 82.7. Very straightforward, everybody. So that means this angle is 82.7, subtracted from 90. 90 minus 82.7 gives you 7.3. So alpha is negative 82.7, and that means this is 7.3. So the actual speed is 447 miles per hour, and the direction is south, 7.3 degrees east. Pretty straightforward, everybody. We're going to spend some time on the second part, dot product. The dot product, product of two vectors has many applications with the following algebraic definition. Vector v and w. V has the component a1i and b1j, or a1b1, and w has different components a2i and b2j, and alpha is a scalar. Now, v dot w, the dot product of the two, we put a dot, is the product of a1, a2 plus b1, b2. The symbol, okay? The symbol v dot w is read v dot w. The dot product is also known as a scalar product or the inner product. The result is a real number, not a vector. The result is a real number, not a vector. Here's the properties. When you multiply them in any order, it makes no difference. V times W, W times V dot W, W dot V. If you dot it with 0, in any order, you get 0. If you multiply the two, V dot V gives you the magnitude squared. If you multiply it by alpha, you can distribute the alpha. And as I said, this is the answer, right? A1, A2 plus B1, B2, right? This is the definition, everybody, definition. And this is equal to the magnitude of V times magnitude of W times cosine theta. Therefore, if I want cosine theta, I would divide the left side by the product of these two. So angle between vectors, cosine theta, is V dot W divided by the product of their magnitude. And again, magnitude, remember, is square root of A1 squared plus B1 squared. We want to find the dot product here. So simply put, multiply their components, -5 times 2, 3 times 6, and add them up. It's really that simple, everybody. The dot product, okay, A1, A2 plus B1, B2. So -5 times 2 is -10, 18. They add up to 8. So -5 times 2, 3 times 6, add them up. If they give us in this format, that means 4 times 3, 6 times -7. 12 minus 42, -30. So dot product, in short, multiply the components, result is a number, is a scalar. Any two non-zero vectors, let's say vector A, A1, comma A2, vector B, B1, comma B2, may be represented in a coordinate plane by directed line segment from the origin O to the points A with coordinates A sub 1 and A sub 2, and B with the coordinates B1 and B2. So this is the A vector, this is the B vector. The angle theta between the two is by definition this angle AOB. And we've already discussed that is their dot product divided by the product of their magnitudes. Okay, we've discussed that already. Orthogonal vectors. Here's the definition. Two vectors are orthogonal when the angle between them is a right angle or 90 degrees. The dot product of two orthogonal vectors is 0 because theta equals power 2. Remember, cosine of power 2 is what? 0. So the numerator must be 0. In essence, you remember two lines are perpendicular, they make a 90-degree angle. Orthogonal is equivalent to perpendicular, but for vectors. Perpendicular discusses lines. Orthogonal is about vectors. Parallel vectors. Two vectors V and W are parallel when the angle between them is 0. The vectors point in the same direction or 180 degrees. Theta equals pi. The vectors point in opposite direction. In other words, V is alpha times W. So the angle between them is 0 or pi. Finding the dot product and the angle between these two vectors. So the dot product is just very simple, right? A1, A2 plus B1, B2. That means 4 times 1 plus negative 3 times 2. And we get negative 2. Now we graph the vectors, and the way we do it is very simple. Just 4 minus 3. Okay, 4 minus 3. One comma 2. And from the origin connected to those points. That's how you graph. And we want to find the angle in between. We are going to use this formula. So this is 1 point. Let me just erase my work. So this point with coordinates 4 minus 3, this point with coordinates 1, 2, and we are going to use dot product over their magnitude. We have the dot product already, we don't have to do it. But the magnitude is square root of a squared plus b squared. So square root of 4 squared and negative 3 squared, square root of 1 squared and 2 squared. Please understand, this is 4 squared or 16. This is negative 3 squared or 9. This is 1 squared or 1, 2 squared or 4. So this becomes 25 or 5. And so we have 2 over 5 squared of 5, negative. So if we multiply by square root of 5 over square root of 5, we get minus 2 square root of 5 over 25. This is the rationalized format, and theta is the cosine inverse of this number, ends up being, using it in using a calculator, 100.3 degrees. So dot product, the angle in between, show that the pair of vectors is orthogonal. So all you have to do, multiply, do the dot product. You know I is 1, 0, and j is 0, 1. So 1 times 0, 0 times 1, they add up to 0, and that's a proof. We do the same thing here. We multiply, and that means 2 times 6, 3 times negative 4. This is 12, this is negative 12. They add up to 0. That's a proof. So how do you prove a pair of vectors are orthogonal? Their dot product must be 0. Show that the two vectors are parallel. There are two ways to do it. I'm going to go over that. The first one is, it's actually very simple. You may notice what's going on, and that is one is multiple of another. I hope you notice that if I multiply this one by 2, I get this one by 2, I get this. If one of them is multiple of another, method 1, notice W is 2 times V, or V is 1/2 W. So one is multiple of another. That's a proof. You're done. The second method is to find theta, and that means we're going to find cosine theta. and it has to be either 0 or pi. Parallel, theta must be 0 or pi. So let's do the math. We get 3 times 6 minus 1 times minus 2. That means 18 plus 2. So this one, again, I want to make sure that we understand this. Let me use a different color. This one class is a 3 times 6 plus negative 1 times negative 2. And this one is a 3 squared and negative 1 squared. This one is 6 squared and negative 2 squared. Okay, very straightforward. So the numerator is 20, the denominator is square root of 400. As you know, square root of 400 is 20. The answer is 1. And if cosine theta is 1, then theta must be cosine inverse of 1, which is 0. So pretty straightforward, everybody. Vector projection. Decompose a vector to 2 orthogonal vectors. So if you have a vector V, you want to cut them into 2 pieces that are orthogonal. So if you have this vector, orthogonal, this vector, orthogonal. That's the concept. So component of V projected to W is V times W divided by the magnitude of W times W, or magnitude of V times cosine theta, or simply V times W over W. That's the idea. So let's read. The component of a V along W may be found by projecting the end point of V onto the line L containing W. So if I want to project it to W, I drop a perpendicular. The idea is that drop a perpendicular. This is the component of V along W. And then the other one is just perpendicular to that. So as long as you get this one, then you make a 90-degree angle and you get the other one. For this reason, the magnitude of V cosine theta is sometimes called projection of V on W. Because what is cosine theta is the adjacent over the hypotenuse, V1 over V. And so if you multiply by V, you get V1. So let me just write that if you want in this case. And this is theta. Well, let me use a different color. This angle, okay, let me actually erase this first and say this one. This angle is theta. So cosine theta is V1 over V. And so V1 is V cosine theta. That's the idea. It's called the projection of V on W and is denoted by projection of V over W, a vector with magnitude of component of V projected W, a scalar. So vector projection of V onto W. V1 is parallel to W, V2 is perpendicular to W, and V1 is their dot product divided by the magnitude of W. And V2 is V minus V1. The two must add up to V. So a simple example to make some sense out of this. Find the vector projection of V, which has the components I and 3j, onto W, which has components I and j. Decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So the idea is that V, remember I and 3j, so you are looking at this one, I and 3j. By the way, 2 represents 1 here. So 1 tick marks is 1/2, just to give you an idea. Okay. This is 1/2. This is 1. This is 1, 2, 3, 4, 5, 6 represents 3, just to give you an idea. Why is that? And W is I and J. See 2 and 2. Do you see that? So you are representing both. And the component, this is coming from the previous section. I'm not going to repeat that. So we are going to just follow this formula, everybody. V1 is this. So what is the dot product of V and W? This is 1 times 1 plus 3 times 1. And this one is 1 squared plus 1 squared under the radical and square it. So in other words, you don't use the radical, times W. So what happens is this is 1 and 3, 4, right? And this is square root of 2, square it, you get 2. 4 divided by 2, you get 2W. 2W. 2 times W, 2I plus 2J. 2I plus 2J. Very simple. Just follow this formula. Let's plug in. Dot product of these two, and then magnitude of W squared times W. So what about V2? V minus V1. So V minus this. So I plus 3J minus 2I plus 2J. And this is class. Let me just write this. So this is I plus 3J minus 2I minus 2J. And these two, I minus 2I is negative I, 3J minus 2J is plus J. So minus I plus J. So what does it mean? V has been cut into two pieces, V1 and V2. V1, we want it to be parallel to W, and it's alongside the W. V2 is here or here, orthogonal to that. Makes a 90-degree angle. Find the work done in pushing an automobile along a level road from point A to another point B, 40 feet from A. So from A to B, while exerting a constant force of 90 pounds. We want to find the work done. What are we talking about? A piece of information from physics. Work is the result of a force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, we use calculus. Work equals force times distance. W equals Fd. So in this case, if the force is 90 pounds and the distance is 40 feet, force F equals ma, weight is a kind of force F equals mg, and work is F times d. This is from physics. I hope you remember this stuff. I don't know if you should have had some basic, physics. But anyways, I'm going over that for you. And so it's just a product, 90 and 40, 3,600, and it's foot-pound. Okay. And believe it or not, it's that simple. It's done. I just reminded of this, and I want to remind you of something else also. Units. Joules, 1 joule is 1 Newton times meter, 1 kilograms meter squared over second squared. Joule, unit of work of energy in international system of units, SI. It is equal to work done by a force of 1 Newton when its point of application moves 1 meter in the direction of action of the force. James Prescott Joule. That's where the units come from. It equals 10 to the power of 7 ergs, and it's approximately 0.7377 foot-pounds. This is just the information from physics if anybody is interested. A child pulls a wagon with a force of 50 newtons. The handle of the wagon makes an angle of 30 degrees with the ground. Find the work done in moving the wagon 100 meters. So the force is 50 Newton. The distance we cover is 100 meters. And the angle is 30 degrees. So we position the vectors in a coordinate system in such a way that wagon is moved from 0, 0 to 100, 0. The motion is from A with coordinates 0, 0 to B with coordinates 100, 0. So it looks like that. So we have to move it from here to here. We're going to move it 100 meters. Work is F dot D. Remember, this is a dot product. Dot product. So AB, the distance is 100I. So this vector is 100I. This is 30 degrees. And this force has a magnitude of 50 with an angle of 30 degrees. So 50 cosine 30I plus sine 30J. And of course, this is square root of 3 over 2. This is 1/2. And the work is the dot product of the two. FD is F dotted with AB. So let's multiply the two. When we want to multiply the two, how do we do that? This is I class. Okay. And so we multiply 50 square root of 3 over 2 times 100 plus 1/2 times 0 because there is no J component there. So 50 square root of 3 over 2 times 100 plus 1/2 times 0. And the result is 2500 square root of 3 joules. That's an exact answer, everybody. That's an exact answer. We use the law of cosine to prove this that was mentioned. So here's the u, here's the v, and here's u minus v. When we have vectors u, v, and this is u minus v. So according to cosine law, a squared is b squared plus c squared minus 2bc cosine a. So this side squared is this side squared plus this side squared minus 2 times the 2 times cosine of in between, right? This is the cosine. Now we are going to look at each side. This one is the same as u minus v times u minus v. I hope you know that. The magnitude squared is the same as this. And this is a u minus v times u minus v becomes u squared minus 2uv plus v squared. And this side is u squared, this is v squared, and this doesn't change. And now these, what color do I want? These two cancel each other. These two cancel each other. This is equal to this, and you can drop the negative 2 from both sides. You can drop negative 2 on both sides. And cosine becomes the left side divided by this. And that's exactly what we had in mind. And again, reminding you of the properties of the dot product, nothing brand new.